Hi, everyone, and welcome back to our next session for Big Data Days 2023. After a very engaging panel discussion, I'm super happy to introduce my next speaker, which is Marek Zieliński. Marek is today presenting from Poland. Marek is the co-founder of 10 Senses, a company that offers advanced analytics products and services, including AI and process mining. He has over 10 years of experience working with data-related problems such as data science, machine learning, AI, and process mining. Marek specializes in data engineering for data visualization, ML and AI, as well as process analytics. He has also worked on using GPUs to support computational performance. He happily shares his knowledge and experience with the markets during conferences, meeting, and training sessions such as we have today. He has a background in solid-state physics and is a specialist in data warehousing MBA, and by hobby, a statistical physicist. Today, Marek will join us to talk about modern data engineering stacks for business intelligence. Marek, it's your first time, I think, at Big Data Days 2023. I'm super happy to have you today. Welcome to our event.
Yeah, thank you for this great introduction. It's a pleasure to be able to speak at Big Data Days. So thank you very much.
Good. The floor is yours. I'm very interested to learn about what you have to tell us and share with us around modern data engineering stack. Take it away.
Thanks. Okay, well, we're past the introduction, so I'll skip it because that's all that's been said. So I wanted to start with a few statistics, and mostly to talk about the risks that are associated with business intelligence projects. And I think that anyone who tried to dig into some more complex data environment would agree. This is actually an uncharted territory. And as they used to put it on maps in medieval times, there might be dragons. So beware. And with the first stats comes actually an interesting story. Well, the original Gartner report from 2015 mentioned 60% of big data projects failing. But after a while, maybe not fully officially, the analyst responsible for the report admitted that it should be closer to 85%. So hence, this is the number that's cited everywhere. Let's also make one thing clear, because the description, I think, might be misleading, because the fail might suggest that there was no final effect. But if you look into the report, this actually includes both, like projects that never ended and projects that did end, and there was an expected result. So the difference is actually about the budget. So this 85% is actually the probability of going over the budget. And if you look at this from another perspective, then there is around 15% chance only that the BI or data-related project, that it will go smoothly, and unfortunately that will fit the initial budget. So other statistics were from VentureBeat from 2019, which is even a little bit scarier, that 87% of data science projects never make it to production. And then the Gartner again with the prediction that from 2019 to 2022, only 20% of analytics insight will deliver business outcome. I have not seen a comment about this prediction, but from what I've seen, this seems to be pretty close to the reality. So I hope that I scared you enough. And if you have any shred of rational thought, like, never start a big data project. Of course, I'm kidding. Like, some of us like challenges and have enough risk tolerance. But seriously, some of those risks can be mitigated, and that's what I wanted to talk about today. So first, the importance of sound data engineering, how big of a part it is for data-related projects, getting from the sources of data to the visualization part, getting insights from this data. I will also mention a few business intelligence trends that we are seeing, either from our own experience when working with clients, talking to colleagues, and also from survey results and from research. One of those trends that I see as important specifically this year is the consolidation of the data stack. I will talk a bit more about it. And one of the reasons for this trend, I think, is economic environment this year. Like the reduction in development team sizes, and companies have tighter budgets. Next, I will be talking about essential data technologies for business intelligence projects. So a few examples, mostly from architecture standpoint and specific data tools, either generically or a few examples, specific examples from Microsoft Intelligence Data Platform, like Azure Data Stack. And last but not least, like a notable mention, because like last year or even 3 months ago, I would not be talking about it yet, because it looked like it would be like farther ahead of us. But after recent advancements in large language models, it's pretty much a must-have, I think. So like cognitive services that are becoming also part of this stack. But it all comes down to how can this all drive value and trust in the insights from data that you're using and the company that we're using. And I would like to put a few concepts in your mind that for me form a roadmap to successful business intelligence projects. So first, this would be data quality. Business intelligence projects rely on accurate and reliable data. You should be able to trust what you're seeing, that's actually grounded in your source data, and correct transformations are applied. And also rigorous data testing comes from this concept. The other thing, data accessibility. Again, this is where data engineering layer comes to the picture. To get your data from the source to a structured and standardized format that allows you to do analytical queries. Then we have data security. Well, you need to make sure that your data is properly backed up, protected from unauthorized access. Next concept, cost efficiency. So optimizing data storage, optimizing data processing, data retrieval. And you want to use the skill set that you have in your organization in the most effective way, especially that those might be pretty expensive and valuable resources handling data. And the last thing is scalability. You might have growing use cases for your data, or like on the other hand, also growing data sources that you want to be able to query this efficiently. So again, optimized data engineering layer comes to the rescue here. And of course, dragons that we want to slay along the way. Okay, so if we ask the simple question, who wants to do data analysis, then we'll probably see a lot of hands, either from business analysts or business intelligence developers or data scientists. And this is what we're taught, actually. But you get data in this nice tabular form, and you can start analyzing it. Seems easy enough. And let's quickly remind ourselves what we're trying to achieve here. So we go from the data sources, go through it visually. We want to go to the visualization part to be able to consume the data, make business decision based on insights from this data, and we need the layer in the middle. So then we ask a different question, like who wants to clean the data? Or actually, let's generalize, and who wants to do data engineering? And then we get a lot less hands and volunteers for that. And the reason might be that there is this real life monster in data. Maybe not always looking exactly like that in the picture, but if anyone in real life tried to dig into data problems, this can get scary sometimes. And challenging, to use a better word. Again, a few numbers from a survey. Why even care about data architecture? What are the benefits of caring? Well, let's ignore the first top answer that we have no defined architecture. That's what we're trying to avoid, obviously. But we see that the main two benefits of caring about data architecture is improved collaboration with the business team and improved collaboration within the IT team. So I would translate that into a trend of cooperation of business and IT. And I think it's like a holy grail of productivity in data-related projects. Like a lot of times we see this schism between IT and data team and business. And sometimes, unfortunately, there's very little cooperation. And from our perspective, handling the data when getting insights from data, this is a crucial part because your data team is trying to do something that should drive business, and like you need at least some hint of what data represents in real life. I will talk about it later also a little bit more. And since I'm looking from data engineering perspective, like for me, the data governance part is equally important as other aspects. And when utilized in a smart way, it can do just that, drive a better cooperation of business and IT and data teams. So that's almost priceless and can mitigate a lot of risks. Here I quickly wanted to point out a few business intelligence trends that I personally see for this year, gathering this from surveys, market research, talking to colleagues and clients. Well, sometimes you see this split, but I put data governance, data literacy, and data-driven culture together. I think they should be considered as a whole. Two main points that make this important: the significance of data-driven decisions is constantly rising, and I don't think there is anything on the horizon that could slow this down. And the second thing, we will very soon have new regulations regarding data and AI. European Union is working on AI Act, it's very close. US and Canada are also working on their regulations. Very recently, we had a hearing in the US Senate about AI regulations. Well, AI providers want the regulations themselves, so this will happen. Then the second trend, consolidation of the data stack, and I would discuss that in more detail. Next, then we also have a slow rise of a separate semantic layer, where we want to decouple measure definitions in business intelligence from the actual BI platform visualization layer, and I'll explain that also. Then data security, I don't think I need to comment on that, just a trend for like a lot of reasons. It would be a separate lecture on just on that. And trend number 5, where again, very slowly and gradually, something that is actually solved in software engineering and is coming to business intelligence more and more, and that is continuous integration, continuous delivery, and automated testing for business intelligence. And the last trend, which I would not consider a few months ago, I guess most of us were taken by surprise, at least I was, how quickly it can grow with ChatGPT being like the fastest app to reach 100 million users in just 2 months. So that's, I think, incredible. And like, however, it still has specific limitations if we think about using it in the like an enterprise usage versus private usage, as it's mostly used currently. So now I wanted to focus on this trend of consolidation of the data stack. And on one hand, till even last year, the data stack was growing almost uncontrollably. That's the black hole in the image, like sucking everything up. Like, and a lot of new data tools, a lot of new platforms. And on the other hand, we have the current economic environment and the drive to reduce costs. So that's the reason, I think, for the reversal of this trend. And we now actually want to get all our tools from the data stack, like integrate them more to have a more unified data environment that's easier to manage. So we want more centralized data management. And like, if we think about ancient times, actually, that's basically all we had: SQL Server, Oracle, SQL, C++, Java, and that was the full stack for doing data engineering. And back then it was not even called data engineering yet. And if we think about it right now, then this picture is like from 2021, still a bit readable, but I hope you get the point. We had almost exponential rise of different tools and tool sets. And if you think from the perspective of your skill set in the organization, then how do you manage all those skills for all those data tools? How do you do that, right? So the idea, I think, is to focus, use the skill set that you have in the organization in the most efficient way. Of course, what you want to balance it, not to have a vendor log. Some variety is always healthy, but I think we're long past the point of healthy variety. And the alternative to consolidation, in my opinion, is that probably most of the time will be spent on learning those new tools instead of doing actual data engineering and getting business insights. So let's go through the essential architectures for business intelligence. Like pretty obvious, we have the old reliable data warehouse architecture where you have enforced schema that's specifically designed for fast analytical queries. Then data lake architecture where you can store data in raw format, allows you to store unstructured data on top of any other type. And like the main point is very fast when you want to save things, throw it there, and is very cost effective as a storage. But you have the concept of schema on read, which, well, it turns out that it's not that easy to implement this concept to be fast enough for analytical needs where you actually want to be very quick with a lot of data. So for now, a lot of transformations in data engineering is needed as an enabler for getting insights from data when you have it in data lakes. This might change, maybe not in a very short term, but I think we're getting there more and more. Like, again, recent advancements in large language models show that we might be able to have a model that will dig into mostly unstructured data and get something out of it. And we have the third concept of virtual data warehouse, where you theoretically, well, practically also do not move data from the source. You have this layer in the middle that enables standardized access to your data and allows analytics. Also, there is also caching for fast querying, but you try to avoid moving data from one storage to the other. And last but not least, a hybrid architecture that connects those concepts above. Okay. And again, I wanted to mention so the same survey from Dataversity, Trends in Data Management from last year. This time the question was about usage of data lakes and the comparison between 2020 and 2022. And if you look like generally at yes and no, then we might say it's pretty stable. Not a lot of change. Well, around 48 to 49% using data lakes, and not using data lakes, it's dropping a bit from 35% to 32%. So something that looks pretty stable. But if we dig a bit deeper into how data lakes are actually used, then the top answer is in conjunction with the data warehouse. So that's a hybrid setting. And here we see the rise of 8% from, it's from 26% in 2020 to 34% in 2022. Then we have the answer of yes, as a replacement of a data warehouse, which is quite stable at 5-6%. But I would think that those are late adopters that just got on the hype of data lakes, not something that you would strategically do right now. And another answer, yes, we use data lakes as its own solution without the data warehouse. And here we see a drop of 8%. So from 17% in 2020 to just 9% currently, or probably even lower. So looking at those numbers, they are confirming that we see, and also what we see in implementing data engineering and business intelligence, it's very clear. The way data lakes are utilized is changing to hybrid architecture. And that's how we arrive at the concept of a data lakehouse. So going from the left, we have the old reliable data warehouse with structured data and for schema, then a data lake where you can throw everything in a cost-effective way, structured, semi-structured, unstructured, doesn't really matter, but it can be garbage in and garbage out. So it's usually harder to use for analytics. And then we have the data lakehouse concept, where you still utilize the storage based on the data lake, but you have a meta layer with metadata, governance, and standardized access for all your use cases. It can be business intelligence, data visualization, data science, and machine learning. Here, let's get back down to Earth a bit. This is data from BIRC survey. They're actually doing a very good job measuring digitalization in business setting. So very good data source to check and follow as a data source for market trends. And the question here was, which technologies you're using for data access? And while there are some voices that data warehouse is dying, will go away, well, the reality clearly disagrees with this. This is quite a recent survey. And we see that data warehouse is there on top with above 70%. So it's still used, and in my opinion, because of schema enforcement, of fast analytical querying, it will still be used for business intelligence use cases. Whenever you need aggregations, that's where it performs the best. Then the second answer on this list is business intelligence in general as a access point for data. While this might sound trivial, but this tells an interesting story that most of data consumers need to be enabled to access the data by this BI layer. And this happens when you are able to move the data from the source through data engineering layer to the BI platform. Then you actually enable your business users to use the data. They're not so keen on digging in the mud of the source system, getting the data from there. So it's pretty important to allow your users to have this access through BI. And the third one, I think immortal Excel, like a spreadsheet, I doubt it will ever come out of use. It's just too useful, too flexible. A lot of times you just want to export a sample of the data from BI tool to be able to dig into like a specific example. That will most likely be Excel. If we look a little below, we'll get to code and here Python, for example, so programmatical access to data. That's probably where Jupyter notebooks would lie and your data scientists accessing data. And the last thing here, probably why I don't fully don't like this question, how it was asked, because it puts a lot of different concepts in one place from different domains, for different categorizations into one. And especially I think there are a lot of misconceptions about data mesh and data fabric. That's something how this is platform versus platform or data mesh versus data fabric. So I think those two should be taken out into separate category. But here we have them because data fabric and data mesh are strategic approaches to data in a company. So you can implement them in various forms, and you can have both at the same time. They're not exclusive, really. So data mesh is something more focused on data as a product with the concept of decentralization and federalization of data, and the data domain oriented. So we have domain oriented data. You get different departments, you enable them to use the data. It's more focused on how you use it. And data fabric approach is most focused on a unified platform. So a way to enhance the data either via AI or trying to build a standardized interface for user to data. So here, this approach is more focused on the platform. But still, data mesh and data fabric are not exclusive. They're implemented using specific tools, and you can implement both by different data stacks also. A few concepts for consolidating the data stacks. So single integrated data platform, you don't really want double-digit number of tools that you need to integrate. We want to lower the number of dependencies between them. Common data architecture, standardization, that of course requires cooperation, but if standards are enforced, it's usually easier. You have like a carved path that you can follow and only deviate if it's really needed. And if possible, reduce reliance on legacy systems, usually introduce overhead. So if it's possible to migrate, that's a good idea. It's not always possible. Then data governance. So like it was the first trend with promoting data literacy, an overview of the data assets that are used in the organization, and then balance between storage versus virtualization. It's not always a good idea to store everything, and that's not always a good idea to like have everything virtualized, because that might not get us enough performance, especially for aggregates and analytics. And last but not least, using data lineage for root cause and impact analysis. So that's actually also a data governance. I will talk about it using a tool as an example. Okay, so essential technologies for business intelligence project. What do we need? First, we need an ETL/ELT tool, and well, right now, if we're thinking about actual implementation, about hybrid architectures, data lakehouses, everything tends to gravitate towards ETLT. So extract, slide transform, hence the small t, and then load and then transform again. And then you need a data storage. And here I put the semantic layer between data storage and BI platforms. And that's because, like, for me, yet, while this is a trend and we're going in this direction, I don't think that there's yet an ideal full implementation of a fully separate semantic layer. So that's why it's not yet a separate feature. Hopefully it will change, as it would have a lot of benefits. Then we have the business intelligence platform, which I think is pretty obvious. And last but not least, data governance tools. So if we look into that, we obviously have data source. The data is extracted. We have the ETLT tool. Then we transform the data and load it. Then we have a data storage. We would like to abstract the data for user-friendly access, so have this semantic layer, and then analyze data and visualize it in business intelligence platform. And we have the oversight of data governance tool. But well, that's a dream versus reality, actually. So we have the first two ingredients, but the semantic layer is usually embedded in the business intelligence platform still. But we do have the data governance tools for oversight. So we're not too far from this dream, I think. Okay, let's start with the ETLT tools. And well, we don't have that much time, so I'll just briefly go through it from a strategic perspective. So on the right, we have ETL tools, which are not necessarily always called ETLT, sometimes ETL, ELT, but if you actually implement it, it's usually a mix, so ETLT. And those are from big cloud providers. So if you have most of your data and organization and it's used to a specific cloud provider, then an ETLT tool from this provider might be a good idea. Usually integration, security, data, network separation, that would be managed better in a single platform. But then comes the question of features and flexibility, ability to access various APIs, ability to code. And then you have providers on the right, so like providers of data tools. So just a few main examples. There are a lot of other tools, of course, but usually the tools on the right can work with those on the left also, but can access different architectures, but it's more so on the right here that you can use storage from any of the providers. Something that's not here, which I would consider a big four in data storage, is Snowflake, but it's a bit odd one here because it doesn't have its own ETL tools. They rely on partnerships, for example, Matillion Talent and Alteryx, and then they provide like the full ETLT pipeline with partners. So going to the next item on the list, so storage, and I left the ETLT part there because the tool I'm talking about from the Azure stack actually implements both. So it's Azure Synapse, and that's actually a platform that allows you to get from your data source similarly as in Azure Data Factory. There has very similar features. But curiously, not every feature from Data Factory made it to Azure Synapse. Like the odd one out is, unfortunately for us, Power Query. You cannot use it in Azure Synapse. You can use it in Azure Data Factory, and the ability to use that lowers the bar for entry for Power BI developers because they already use Power Query for transformations. But essentially, here you get a web studio where you can define data integrations, data pipelines. You can manage and monitor those pipelines and handle security. You get two analytical runtimes, one is SQL, the other Apache Spark for custom transformations and injecting machine learning. I will show an example of our architecture that we did using that. And it's all backed up by data lake storage. So you get a data warehouse, metadata layer, and it's all backed up by a data lake. So, well, from my perspective, that's a data lakehouse. Like, curiously, it's not called that by Microsoft yet. By itself, it's not yet a tool that would be enough to implement, for example, a data mesh. But it can be used as one of the components to implement like those strategic approaches. Another like simple example, also from Azure Stack, that's actually realizing also ETLT and storage is Power BI data flows and Power BI Power Platform data flows, which are part of Power Automate. And curiously, this being very simple tool actually, but quite powerful, I think. And they are available for a few years now. So it's puzzling for me that it's still underutilized among Power BI professionals. We used it for our clients since it was in public preview, and I think it was 2018. Now it's a production feature. So what it actually allows you to do is to take the Power Query part, the code, and put it into a separate data flow in the Power BI service. And it can run independently on the same capacity, same compute capacity as then would be available for the BI report, and data will be saved most often on the data lake. We used it for performance optimization, also where we needed to reuse data assets in different pipelines. So this is what you can use it for. You extract certain parts of data transformation into separate data assets, and that's usually easier to manage. Then we go to like another concept, maybe not exactly realizing storage, but it's still in between the storage and the BI platform. And it's also not yet a fully independent semantic layer. But this is a concept from the data warehousing domain. So like Power BI Datamart, that's a very recent introduction, like very welcome introduction. And since this is actually a concept from data warehousing and business intelligence, so this refers to a smaller, more focused subset of organizational data, where you can do ad hoc querying, and it realizes decentralization and federalization. So it's usually focused on one domain, for example, just finance or just sales. You put specific domain-oriented data into specific data mart and allow selected departments or teams to use the data that's there. It's usually also customized and tailor-made for those specific use cases, specific users groups. And thanks to the limited scope, it can have better performance. I will skip business intelligence platforms because it's about data, like that would be pretty obvious and maybe a subject for another lecture. So I go to the data governance tools because that's an oversight into data assets. And here also a quick example from the Azure stack, Microsoft Purview, and I must say that the road it traveled, well, it was a different tool back then, like the data catalog that was completely unusable, but the road it traveled to what Purview is right now, like that's really something. And like in my line of work, I constantly compare different data governance tools, mostly from data engineering perspective. And Purview, in my opinion, is a very focused tool. It doesn't have hundreds of features. It has few most important things that you actually need. So this is data catalog, data map with a glossary, and this allows you to access data assets and connect them to business meaning. So just to quickly go through, you define data sources, you define scans, then you can automatically scan your databases, data sources, ETL tools also, and you get the data assets in there. Then you can build data glossaries or business glossaries, and you put definitions of the business meaning assigned to specific things, and you can link it to data, either tables, data flows, or even columns, and you can make a link between data assets and a glossary item. So from the business perspective, you can actually go from a business concept to how it is represented in your data. That's not always that clear. And from data engineering perspective, you can go into a specific table, specific column, and see what it represents in real life as a business concept. That's also not very clear sometimes, and that would be good to know. And finally, data lineage. And like what's important, also end-to-end data lineage, which is like even more exciting from my perspective. So where you can go from end to end, and it allows main two things that I already mentioned. So one would be root cause analysis. So you go from the right side, from business intelligence report, and through transformations to the source of data. So like, let's check what happened along the way with the data until it reaches the destination, and like, find if anything goes wrong along this path. And you can also go in reverse. So from the data source, again, through any transformations to the destinations, and it can be multiple business intelligence reports or data marts or analytical views. And then we can do impact analysis. So we plan a change and we can immediately see what influence and where would it have going forward. That's pretty powerful. And I would agree, unavoidable when you want to implement data-driven decision-making. The next thing, you can go to column level lineage. So we can actually trace a specific column, how it goes through the transformation report. I sometimes see very curious things when like a column is actually traced through what happens with the data. And you finally get to the level of data activities. So currently, if you have to stay in the Azure stack, you can scan Data Factory. So that's a potential benefit of like consolidation and staying in one platform. You'll get also activities that are performed in ETL. That can also be useful in your data lineage. And the last part, Purview is based on Apache Atlas API, so we can programmatically push changes to Microsoft Purview. And that allows quite a lot of flexibility when you can programmatically push changes to your data governance tool and integrate that with infrastructure as a code. Just a short intermission. We usually want to gather as much feedback from the market and from community. So like here, we invite you to take a short survey. You can use the QR code or link to access the survey. If you want to leave us business details, we have 3 prizes for participants of Big Data Days this year, in the form of free workshops focused on your BI and data needs. So if you just want to leave feedback, then we'll appreciate that. It's always good to stay on top of actual challenges people face. So, and we'll be sharing our findings, of course, in an anonymized way if it's not connected with the workshops. So after like short intermission, let's quickly go through some examples of architectures from our projects, well, not like this architecture and this AI-generated image, but I mean system architecture. So it starts pretty standard. On the left, we have data sources, database, external APIs, and virtual network. So for database, we used native connectors from Azure Synapse. That was pretty fast. We had external APIs. So for accessing those, we needed an authentication layer, and that's where registered app and Azure Key Vault comes into place, where we securely stored credentials. That's the recommended approach. And some of the APIs had hierarchical structure in the responses, so that was not easily translated into tabular form natively. So we needed custom transformations that we've done in PySpark notebooks here. And some data sources were behind a virtual network, so that's essentially on-premise data sources usually. So here we used a separate data factory that had access to those virtualized networks. So it just copied the data into the data lake Azure and Azure Synapse. So again, a secured link with just this part that could be passed on. And what's important from also data engineering perspective about both Azure Data Factory or Synapse, it's even those that are local tools, and this is also a trend, they are still defined by, for example, config files in JSON structure. So underneath, they are usually code. They are still defined by this. So this allows to utilize concepts like code versioning using Git and implement continuous integration, continuous delivery concepts, for example, using Azure DevOps. That's what we did in this project, going from the development workspace through branches, master branches, publishing everything with like triggering Azure pipelines to get to test and then to production. And another architecture, this time utilizing Datamarts. And this actually can be an implementation of a data mesh because it's utilizing here the concept of decentralization and focused data marts with data as a product. So again, going from the left side, we have data sources, the authentication layer with registered app and Azure Key Vault. And the data is moved to separate data flows. Essential transformations happen there. So that's the storage part. And then based on this storage, we can focus on business domains. And so one data mart would be finance, therefore sales. Yet another could be operational processes. And then BI reports for visualization and easy access. And of course, data marts also allow either data teams or business users to have an easier access to their data that they understand. And last but not least, on the very bottom, here Microsoft Purview, but a governance tool to provide oversight, scan data assets, and essentially handle the data governance needs. So let's quickly recap the benefits of sticking to one data stack with the example of Azure here. So first, it plays to the trend of consolidated data stack. You get a data lakehouse, your Azure Synapse, then you have a Power BI platform, which represents the whole service. So data flows, data marts, so we can implement data mesh approach with those tools. And last, Microsoft Purview with oversight and governance. And quickly, as I ended in my agenda, like I wanted to mention one more component, which until recently it was more of a hype and an enterprise-ready solution. But still, even now, most accessible way to use GPT-4 is via OpenAI offering. But Microsoft seems to be working hard to making it ready for wider business use cases with their Azure OpenAI services. So NVIDIA aims at providing computer sources for foundational models for us to use. So we might expect to see this develop from different providers and actually be able to use it in an enterprise setting without worrying where this data goes to the server that it shouldn't be going to. Well, the access is still limited, but it looks like we can inject it into BI pipelines also. Currently, you have to submit a request first for Azure OpenAl services, then another request for GPT-4. Microsoft would review your use case before granting you this access. I'll quickly skip. This was like diagram generation, which the main point was that you can get structurized code out of large language models. So that's one point, but you can also send structured code. So here, like a short tech demo that we did, like very simple visualization about sales in different regions. On the left, just a map showing bubble size based on sale quantities. On the right, pricing, trend per region, and trend for sales quantities. But what I actually wanted to show is that you can represent this, the charts and the underlying data, as a JSON formatted data. That's seen on the left side: product, quantity, price, date, region. So we can pass this data, and we can send it via API request with a bit of prompt engineering to a language model. And for example, we can ask it to provide us some insights from this data. It can already be aggregated, but we wouldn't be able to send big data there, but something aggregated. And also, like, the limit of what we can send, it's getting bigger and bigger. So we're actually, I think, getting there. And like here, a short example with the prompt, you can force it to return data in your specified format, giving it an example. So like the prompt we used was close to something here, asking it to return insights and recommendations as another category. And we ask also for like numerical confidence, which also can be done like as a quick check if it's something that can be regarded as an insight, or perhaps there's just 50% or lower. So it's just an uneducated guess even. And so going back to our pipeline, there's one part that's usually needed for a practical implementation, where you do this feedback loop where you pass the initial response back for like a quality check or self-correction. This usually, and it's not just us, you can see this everywhere, it usually greatly raises the accuracy of the response. And we can get the response in this structured way that we specified with the specified categories. Of course, without rigorous testing, this confidence, that's just a rough indicator of when something goes bad. But if we have the JSON response from the API, we can parse it in Power BI and show it as a visualization. And since here it's a text-based, then four-butted table does work. So here we have insights, recommendations with specific subcategories with the text and confidence. So just a short demo, that's something like injecting this into Power BI workflow is possible. I think we're close to the time, so I'll just quickly skip this just as a overview that we might be getting soon to garbage in, insights out. We're probably not there yet, but something that's I think on the horizon. And if you think about it, there is actually like law enforcement does this, so perhaps it's still possible that if you get garbage in, you might get insights out. So like, let's recap. To summarize this, we talked about like the importance of sound data engineering, how big part of it is, and BI projects. The trends in business intelligence, one that I think it's good to focus on is consolidation of the data stack. You get benefits from being more focused, more effective with your skill set in the organization also. New possibilities, thanks to large language models, I think are coming pretty soon. Of course, not everyone needs it right away. You might also not be ready for it if you don't have a stable BI solution and like business intelligence reporting yet. And a better approach is to take it step by step. Start with something small and manageable. Then when a solid base is built, understanding of the data is built, there is some governance and promoted inside the organization and actually used, then it's a good time to consider adding like a use case for something more complex. And going through all these benefits, what we ultimately want is valuable insights and insights that we can trust from our data. I wanted to leave you with a quote from Jim Bergeson: "Data will talk to you if you're willing to listen." And a short reminder about the survey, if you can use the QR code to get the link. There are 3 prizes with the workshops. There, I think we have time for a QA, I hope. But if you can also reach me here via LinkedIn or via email.
Thank you so much, Marek. This is a very insightful presentation. I don't know if you kept an eye on the chat while you were talking, but a lot of people really said that they really liked your approach towards different architectures.
I actually have not, so I'll do that.
Well, I'm already would like to invite you for another follow-up session in which we can go through some of these architectures a bit more in detail. I know that time is short and you covered a lot of different aspects. While you were talking, there were also a number of questions coming in. I don't have time to go through all of them, but let me just ask the question which had the most votes. And that question is coming from Michael. Is the question, let me project it on the screen. What considerations should be made when selecting and implementing a modern data engineering stack for business intelligence? So what's your primary consideration? Just within 1 or 2 minutes.
Yeah, so I think I hinted to it a bit, but first I would think about your current data environment. So are you using a single platform, single cloud provider, or maybe it's diverse? How many legacy systems do you have? And something that's, I think, very important, how flexible you need to be, because if you have a lot of external services that can only be accessed via APIs, you need a tool that is flexible, that you can actually code. I would not suggest low code or even no code tools if you need to access, for example, APIs. If you keep it in one platform, then perhaps no code, low code tool would be enough. Just copying it, but if there's APIs involved and sometimes they don't have very good documentations, you might get surprised by what's comes. So then flexibility is something that you can actually use code to even access the API, but for sure be able to transform it. So that would be one thing. I would definitely look for a tool with the oversight, something like for data governance, where you're able to do data lineage and both root cause and impact analysis. Well, I found it to be greatly helpful when you can visualize this part that's not always possible. And I would also look for column data lineage. It also helps. So
good. Thank you, Marek. This was a really excellent session. I hope you enjoyed your first time presenting at Big Data Days. This was an excellent session, and I think a lot of people really, really enjoyed this. So thank you so much for your time.
Thank you for the opportunity.
Of course, more than happy to. Our next speakers are already waiting, because in 5 minutes, we're going to start the next tracks. In track 1, we will be listening to Mohammed Baida, who's going to talk about detecting hidden UHNW customers in banking. And on track number 2, we have Trista, who will be talking to us around building a big data business around open source. So again, I know very difficult choices to choose from, but take your pick, and I will see all of you back 5 minutes from now. Thanks, everyone.